What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at solving absolute value equations and inequalities. And this is going to be part one of this series, so let's go. Now, when we talk about absolute value, the absolute value is the distance. So I want you to write this in, the distance, D-I-S-T-A-N-C-E, the distance a number is from 0 on the, I'm just going to abbreviate number line with hashtag on a number line. So distance a number is from 0 on a number line, and you'll see that it's absolute value. You'll notice that because they'll have this symbol that you'll see right here. It's kind of like two bars like that. Remember from geometry you had parallel lines? Well, this is like something is stuck in between that. So that's the absolute value of 7. Now think about this, because it says solve and graph. So if I think about the number 7, so here's the number line. 0 is going to go in the number line. Now we've got 1, 2, 3, 4, 5, 6, 7. So that spot right there, 7 is 7 away from 0 on the number line. And also 1, 2, 3, 4, 5, 6. Negative 7 is also 7 spots from 0 on the number line. So graphically, that's what that would look like. You'd have two dots, one at 7, one at negative 7. You can even simplify that sometimes, because sometimes people just put these three numbers on there, 7, negative 7, and 0. And you'll put a solid dot right on those values right there. So that could be one way you denote it as well. Now, the solution for this, so x could be equal to 7, or x could be equal to negative 7. Those are the two ways you could write that. You could also write it like this, negative 7 and 7. So you could write it both of those ways, but then you put a little curly brace around it. So several different ways you could notate the solutions for that. Now let's check out this one here. Check out number 2 here. This one, we got a little bit more work to do here. So when you have an absolute value where you got stuff in the middle in between this, you're going to take the value and you're going to kind of split this equation into two pieces. So I'm going to kind of roll that over here. So you're going to have x minus 17 equals 38. So that's going to be one piece that we're going to solve. And then the other one that we're going to solve will be this other guy, which is x minus 17. So and equals negative 38. Now notice, what's the same in both of these? Yeah, this part right here, x minus 17, samesies, samesies. All right, so that's the same. The only thing that changes is that we're going to have a positive 38 or a negative 38. So that's one of the keys to doing that. Now, once you set this up from here, it is just basic arithmetic. So if you add 17 to both sides, you will get 55 for the left version. And if you add 17 to negative 38, so on this one, you'll get negative 21. So these are our two solutions, x equals 55 and x equals negative 21. So again, when we graph these on the number line, all right, so here's 0 right here somewhere, and then negative 21 would be way out there somewhere. So negative 21 and then 55 would be over here. So both of those would be our two solutions to our absolute value equation here in example number 2. Now, sometimes when you're writing your number, you might also see, so I want you to add this to it, because the number line keeps going in each direction. So I apologize, I didn't do that. Let's add that on to the first one there too. Make sure you have the arrows on the end, because the number line goes on forever and ever, bro. Never ends. Now, some way you might see that written a little bit differently. You could see, ooh, that's gross. We're not going that thick. You might see it written like this, where you have 0 here, and you got your 55, and you got your negative 21. So sometimes you might see just a dot written above it, like that, because later when we do the inequalities, we'll do some shading at different pieces. So those are two different ways you could notate that. So be sure you check with your teacher if they prefer one answer over the other one. But in either case, we get these two values of 55 and negative 21. Now in example number 3, let's check this guy out. Ooh, we got a lot more stuff going on. Yikes! So, very first thing you want to do, so this is going to be multiple steps. You're trying to get this chunk right here, whatever's in the absolute value, you're trying to get that and isolate that by itself. So this will be several steps to do that, and then we'll do the same thing that we did in example number 2. So let's start by taking this problem, and we're going to first Let me rewrite it over here because I want to keep my work nice, neat, and organized. So x plus 2, the absolute value of that, and then minus 4 equals 14. So I'm going to add 4 to both sides first. So I still have 3 times the absolute value of x plus 2 equals 14 plus 4 gives you 18. Next, you're going to divide both sides by 3. So you get that absolute value part. The absolute value of x plus 2 equals 18 divided by 3. We know we're good with that. That's just 6. So notice what we did here, yeah? We had to get this x plus 2 piece isolated, which meant these other pieces around it, this 3 and this minus 4, they all had to go over the other side. All right, once we get all of that done, then we are good to go. And then set up our 2 pieces. So one piece, again, we're going to have x plus 2 equals 6. So x plus 2 equals 6. And then we'll do our other piece, we x minus, or plus 2 equals negative 6. So those will be the 2 pieces we set up. And when we subtract 2, we will get x equals 4 and x equals negative 8. So these are the 2 values that I get. Now, we got to check ourselves before we wreck ourselves, bro. So when we go to do the check, we want to make sure, so let's see, so I'm going to make this a little bit smaller, because I can do that, so I'm going to make that a little smaller, there we go. And we're going to check both of those in the original problem to see if what we get is correct, because sometimes we make an arithmetic mistake. We can't let arithmetic slow us down. So first, we're going to check x equals 4. So, all right, let's go. So we're going to have 3 times the absolute value. Now we're plugging in 4 for the x. We're going to have 4 plus 2 in the absolute value, and then minus 4. And we want to see if that is equal to the 14. So let's do the arithmetic. One step at a time. 3 times the absolute value, 6, minus 4. Does that equal 14? About to find out. Now the absolute value of 6 is 6, so that's cool, because sometimes you might get a negative number in there. No big deal, but when you take the absolute value of a negative or a positive, you still get a negative value. Then minus 4, we want to see if that's equal to 14. 3 times 6 is 18 minus 4. Is that equal to 14? Yeah, it is. What? Kuya! So that works. We good there. Now we're going to do that same thing with my other x value, which was negative 8. All right, so when we check negative 8, so same thing. X equals negative 8. And you want to take your time, because as you go through and you do this, it's really common to make an arithmetic mistake. So that's just be careful that we don't do that. So again, we're going to have 3 times, and in the absolute value, in x's place, we're going to plug in negative 8. So we're going to have negative 8, and then plus 2, and then minus 4. And again, we want to see, does that junk equal 14? When we get all that stuff combined, do the arithmetic on the left side, do we get 14? Look, I'm already thinking crazy in this. I'm writing negative 14. Does that equal 14? So the absolute value of negative 8 plus 2, we get negative 6 minus 4. Does that equal 14? About to find out. Absolute value of negative 6, again, that's 6. And then minus 4, do we want to see, does that equal 14? Okay, 3 times the absolute value of 6. Ooh, the absolute value of 6 is just 6. And some of you might be able to skip a step or 2 in here, so that's cool. But we're just checking to make sure that we're good. 3 times 6 is 18 minus 4. Does that equal 14? Yeah, 14 equals 14. We good to go, bro. So both of these solutions do work. All right, because sometimes we get answers that don't work, and we'll talk about that shortly. Very special kind. So our solutions are both 4 and negative 8. X equals 4 and x equals negative 8. Now let's talk about number 4. All right, so check this guy out. So we start out with negative 2, and then the absolute value, x plus 7, equals 22. One of my favorite numbers, but don't be blue. Now there's one thing we got to do, and that's just get rid of this negative 2 right there. So be careful. A lot of times I'll see students that want to distribute that negative 2 in there, and those are not parentheses. They're absolute value bars, so don't fall for that. Now we'll divide both sides by negative 2, and then you'll get the absolute value of x plus 7, and 22 divided by negative 2 is negative 11. Whoa. Whoa. All right. This is nice. This is easy, because we are done. You know why? Because this value right here is negative, and you can't have the absolute value of blop some stuff equal to a negative number, because distance from 0 is not going to be negative. Now later in other courses you'll talk about moving left or right, but for now, this spot, you can't have the absolute value of anything equal to a negative number. So there is no solution. So that's what we say when we end up with something like that. All right, so there's no solution to this problem. All right, so that's it for these first 4 examples. And the next 2, so I'm going to come back in another video, but I want to make sure you're solid on this, that you're good on all those pieces. So come on back and watch the rest of it, where we'll do examples 5 and 6 in one video, and then we'll get into all of these other ones. Cool. All right, I'll catch up with you guys later. Peace out.